morning, everyone, and welcome to the Silicon Photonics Fueling the Next Generation Revolution. I'd like to introduce to everyone James Carroll, who will be facilitating this session. And Jim is the editor and founder of Optical Networks Daily, and he's also the editor and founder of Converge and Network Digest. So this will be a 40-minute session with an additional 15 minutes or so for Q&A. And so at this time, I will hand it over to Jim.
All right, thank you, Nancy. Really appreciate that. So this is the first in a series of webcasts that we're doing that are being brought to you by COBO, which is the Consortium for Onboard Optics, and by DuPont. The next webcast in this series is going to focus on co-packaged manufacturing, and it will be presented with IBM and Global Foundries on September 16th. It's also a free webcast, so I encourage you to join that one as well. We'll have registration information posted shortly. So COBO, as you might know, is working to develop specifications that permit the use of board-mounted optical modules in the manufacturing of networking equipment, switches and routers and servers. It's a very interesting organization, a very future-oriented organization, and I think you're going to see a lot more from them. And DuPont, our other sponsor, is of course known for being a leading supplier of advanced materials for fiber optics, and material science is really fundamental to what we're talking about. So today our topic is the groundbreaking book, Silicon Photonics, Fueling the Next Information Revolution, written by Daryl Inniss and Roy Rubenstein, both who are joining us on this webcast. The book, if you haven't already purchased it, is available on Amazon, so I would encourage you to do so. It really does give you a wide range of information on this topic. So with that, welcome, Daryl. Welcome, Roy. And let's get started. Our first question basically would be, tell us about your book. What got you started?
Yes, good morning, good afternoon to everyone. This is Daryl Inniss and Roy Rubenstein. Roy, say hi.
Hi.
Okay, I'm sharing my screen, so hopefully everyone can see the slides that we prepared for this presentation. So the idea is that we're going to spend the next 40 minutes or so going through an updated perspective of Silicon Photonics and fueling the next information revolution. We started, I'm sorry?
I also just wanted to jump in and remind everybody that if you have questions, please use the Q&A function in the webcast, and we'll be getting to as many of them as we can at the end of the presentation.
Thank you. Yeah. So for those who have not seen the book, what you will find is that we start each chapter with a quote from a luminary in the field of Silicon Photonics or optics or communications or what have you. Roy, what are you thinking? We have some quotes here. What do you see?
Okay, so really there's two quotes out of these that I want to highlight. The first is, we recently spoke to Professor Batts, who's obviously a Silicon Photonics luminary, and he made the observation that Silicon Photonics is at an inflection point and there's going to be change. And what he was referring to was really the use of Silicon Photonics for other markets besides the to-date traditional ones of telecom and datacom. So this is an important time, and so we certainly wanted to highlight this, and we'll talk about the second wave in a bit. And the bottom quote, again, wasn't talking about Silicon Photonics, but it very much resonated, because what the quote is from Glenn Gore of Amazon Web Services. He was talking about cloud provider working with telcos in terms of what's going on there, but he was making the point, and this is what resonated, that occasionally there's a convergence of technologies or a confluence of technologies, and when it happens, and it doesn't happen often, it basically sort of sends shockwaves through the industry. And this leads us on nicely to sort of the motivation for our book.
So let's get cracking here. So by way of agenda for today, what we're going to do first is give a description of the book and what's in it, a bit of background of what that exercise was all about. Then we're going to spend some time focusing on developments since 2016, and that points to some issues, including the forecast for Silicon Photonics, where we'll show that the outlook is bright. We expect to see growth. We'll also spend some time talking about the ecosystem, where we show that a number of companies are aligning themselves to support the evolution of the technology. And then we get to the exciting topic of co-packaged optics and the demonstrations that have been announced in 2020, and how and why this is an important advance that supports the establishment of Silicon Photonics in the marketplace. We talk a bit about the outlook using switch technology and what's needed there. And we end this section by talking a bit about the supply chain, because this brings together two critical markets, optics and photonics, and what does that mean in terms of how the supply chain evolves with time. And finally, we spend time talking about a second wave. Much of the work that's happening now is about interconnect and communications, datacom and telecom, but there is an entire new market in a number of different segments that plans to use this technology, and at present, solutions are being developed that will come to market in the years to come, and that has already started. We end by talking about the 2020 takeaways. Where are we now, and what does this mean in terms of an outlook? So, Roy, hey, why did we write the book?
So we saw several trends coming together. So again, going back to the quote we were referring to. So this isn't new, but the growing importance of the web scale players, in addition to the traditional market of telcos, and with each year, their influence was growing, and also what they were doing. So there was clearly a sort of a new input that was having an effect on the industry. There's also the issue of Moore's law slowing down, and this is important because it requires a change of thinking. Up till recently, it was very predictable in terms of the performance improvements, and once that starts slowing down, new approaches need to be thought of. And Silicon Photonics is one of them. In other words, this is what's referred to as beyond Moore's law technologies. And then lastly, traffic is continually growing. And so at some point, this has an effect on what's being done here, whether it's parallelism or capacity crunch of fibers in terms of what's being done in telecom. So these were trends going on in the background. And at the same time, there was a lot of attention being given to this relatively new technology. And we wanted to assess what the technology was capable of, but also look at it in the context of these more general and more significant trends in the marketplace to see where it would fit in. So that's what started us off in terms of doing this book.
So Roy and Daryl, could you maybe tell us a little bit about what you were doing when you started this? I mean, where were you working? What was your background? This is 2016, right?
That's right. And so just to give a bit of context, Roy and I, we met each other in 2001, 2002, doing market research for a firm called RHK. And so much of our thinking started there many years before the book ever came to fruition. In 2016, when the book was completed, I had just transitioned from doing market research to working at OFS Fitel, which is where I am now. But much of the work, the writing of the book and so forth, was done when I was still doing market research.
And very briefly, I'm the editor of Gazettabyte, so I've spent a lot of years covering this technology and covering different aspects of the industry, both in telecom and datacom. So in a way, I had a very interesting archive, plus pursuing this technology over time. So we had a great starting point, which we then started to dive deeper. So,
but the thing that struck us was that there were lots of changes that were happening in the marketplaces, and it's the confluence of these changes and the movement of silicon photonics that caused us to kind of alight onto this. The last bullet item on this was also an important element. There's also a lot of myths that surround silicon photonics. One, I'll just mention, people talk all the time about cost reduction, that this is going to be the lowest cost and blah, blah, blah. And I don't think, as you go through the book, I don't think we even make that argument, because in the research and the work that we did, while you can extrapolate and argue that, yes, that can be a significant factor in time, we're nowhere close to that. That's not, right? So we spent a lot of time talking about solving problems that are important, critical problems to the marketplace today that couldn't be solved any other way. So the way silicon photonics, typically in optics, the way it's happening is that we're bringing something to market that couldn't be done in another way. One important factor or interesting factor is that this book is telling the story about a key technology that's coming to market. It looks across the optical and chip industries, which is interesting in its own right. It focuses on telecom and datacom because that's the primary market and opportunity for silicon photonics. And it highlights voices of key silicon photonics luminaries that play a role in this market. I think that it's equally important to point out what this book is not. So it's not a traditional textbook. It's not a compendium of leading academics' latest research. It's not a how-to book. It's not a detailed market research report. It's a very different book than we've seen that stands typically in the economic techno part of the canon.
okay, so this slide is a busy slide and it's almost legible, but really what we're pointing out here, again, just to set the context before we get going as to what has been happening, it's the shape of the curve that's important. So we wrote the book between 2014 and 2016, and it's been about a decade of significant research perfecting the building blocks that you need to make optical circuitry using silicon photonics. And then there was this hype curve where there was a load of attention given to silicon photonics. There were some high profile acquisitions of startups. And then when we started the book, it was a quiet period, and it does meet nicely this classic Gartner curve where what was really happening was companies were embracing the technology and starting to get ready to bring their products to market. So we started in 2014, and as we were writing the book, more announcements started to happen of actual products. And of course, this productivity line has just continued in an interesting way again, which we'll come to. So this is just to point out where we were when we were writing this book. Okay.
We also wanted to make sure that we were all at the same level thinking about the promise of this technology. And so there are a number of tenets that we point to. So compared to copper, low power consumption, low heat generation, helping to reduce cooling requirements, these are quite important, perhaps one of the most important elements for data centers today. And so this technology really supports the evolution of what's needed to support the growth of data centers. In addition, increasing distance. This is one actually I heard most of coming from Intel at the time. that talked about the disaggregated servers. And so just the whole discussion that now that you have high bandwidth connectivity, you need not have all of the piece parts of a given hardware right next to each other. And Silicon Photonics, of course, supports distances from thousands of kilometers to as short as centimeters. High bandwidth, parallelism, that includes both high bandwidth per lane and also supporting multiple lanes with things like WDM. And then, of course, small size integration, both integrating optical functions and then the potential, at least, to integrate optical and electrical functions.
So here you didn't put the cost one on either as one of your factors.
I'm sorry?
You didn't consider cost?
Exactly. And as I said earlier, it's an important element and it comes up later and we'll show it later. But no, it will happen, but of course it takes time and it's all about volume. And so being careful not to jump in and say, hey guys, you're going to get something that is better than, cheaper than, and so forth. That's not the situation. It's going to take time to get to that, to fix that. But there is an example in here where cost is an element.
Okay.
Okay, so just a slide back, Daryl, please. So this is the meat of the presentation, and sort of if we can ask you to bear with us, because there are quite a few strands to what's happened in the last 4 years. And basically we're going to spend a slide or 2 slides on each of these topics. But these are all important themes, and when we come to conclusions, we'll pull it all together. So next slide, please, Daryl. Right,
so everyone is always interested in knowing where we stand from a market sizing perspective. And so Light Counting was kind enough to allow us to share some of their latest data showing that for transceivers and active optical cables and embedded modules, products that are based on Silicon Photonics technologies have commanded revenues on the order of $1 billion per year, both in the 2018 and 2019 time frame. So that's quite good considering where this technology had been. And the outlook in the 2025 time frame, the projection is that some 45% of the total market, roughly $6 billion, Silicon Photonics would account for some $6 billion.
Yeah, and basically that it's almost accounting for half the market. So the sort of the benefits of Silicon Photonics and the use of it is starting to take a greater share. And then just one other comment, this is what you want with an emerging technology. You want it to generate revenue and growing revenue. And of course that revenue can then be fed back to develop future products.
Is there a point where you would say that based on the market sizing that it becomes a mainstream technology instead of an emerging technology?
Jim will come to this. We will come to this.
Okay.
And so we look at the landscape, and the landscape is constantly evolving. These are usually based on strategic decisions, their acquisitions, their partnerships, their even folds where companies and organizations are leaving the market. But one of the big pieces that we found is that the foundries, their strategic partnerships that have been formed with some of the major foundries like TSMC and like Global Foundries, and this is an important element to moving the technology from, say, a niche to mainstream.
And in terms of joint ventures and strategic collaborations, well, I'll let Daryl talk about the strategic collaborations, but just in the joint ventures. So this is one example, and in a way it's showing the growing maturity of the marketplace. And so what we're highlighting, Rockley Photonics with a deal with Pengtong Optoelectronics, a Chinese module maker. So Rockley Photonics is developing optical engines, and so this can be used for pluggable modules, but it's really ideal technology for what we're going to talk about, which is co-packaged optics, sort of putting photonics and co-packaging it with a beefy digital chip to bring optics right next to the chip. So what are we highlighting here? The fact that Rockley is addressing co-packaged optics, but that is a market that's still to take off. So in the meantime, it's using the same building blocks to actually address a marketplace that's selling now, as in pluggable optics. And equally, it shows that you can be an optical module maker, not necessarily make your own optics, which is perhaps a little bit different from how it used to be. So again, just an interesting example. And then it leads on nicely to the strategic collaborations one, which I'll let Daryl talk about.
Right, strategic collaborations, important element. We talk about it a bit later, but this is a necessary part of the market. At least the examples that are illustrated here. So these are companies coming together to help build a system, right? So you have a chip on the one side, and you need to get the light off of or out of that chip onto an ASIC, off the ASIC, back onto the optical chip, and then out into the real world. To do that, it requires a number of different expertise that may not all reside within one organization, one company, and so these relationships are built in order to realize the added benefit of the performance by these chiplets as they are connected to these ASICs. So both Renovus working with IBM and TE Connectivity, and Senko Advanced Components, and then we have Rockley with Acton and Molex and TE Connectivity, and there are others that are perhaps not haven't been announced, but there are other informal relationships because this is a critical problem that's needed, and you need to work across companies in order to solve these problems.
Okay, and then we come to acquisitions, and this is something that we saw even before we started the book. So the trend of large system vendors acquiring Silicon Photonics expertise through acquiring startups. And this trend has continued. So we're highlighting two. Cisco's been active again. It's bought Luxtera to give it a datacom arm, and of course Acacia. And more recently, there was the Nokia Elenion. Each of these are interesting examples. But in essence, what we're showing here is that system vendors are bringing this technology in-house, to solve problems that we're dealing with now. But it's also strategic because they see things coming, and we'll talk about that. But then I also want to highlight the two bottom examples, because this is examples of, in a way, the other side. So Broadcom has sort of reacquired an optical arm. And again, Broadcom's a very important player in the data center with its Ethernet switch chips. And here we're talking about Intel as well. So everyone knows Intel is a chip company, but of course it's an important Silicon Photonics player. And the acquisitions here aren't Silicon Photonics players, they are chip companies. But what we're highlighting is that we're highlighting Intel as a Silicon Photonics player, but we're highlighting how it's complemented its portfolio of componentry in the data center. And in a way, it's got a complete portfolio. So it's obviously got the server chips, which it's known for. It's now got switch chips. It's got FPGAs. It's acquired an AI chip company. So these are all the key elements, accelerator elements that you need in the data center. And it's got Silicon Photonics expertise. And of course, you can do very interesting things by combining the two. So we wanted to highlight these acquisitions as well. And just one final comment. So Mellanox, in that hype curve period that we showed earlier, Mellanox actually acquired Katura. So this was another example of a system vendor acquiring Silicon Photonics. But more recently, it actually let go of that division. In other words, it made a strategic decision that it wasn't benefiting their bottom line. As a result of which, it got rid of 100 plus Silicon Photonics expertise, engineers and expertise. And of course, subsequent to that, NVIDIA acquired Mellanox. And then of course, it's a speculative question, but what would a company like NVIDIA, with all its activity in the data center, with its GPUs and addressing sort of huge AI problems in the data center, what would they have done with an in-house 100-plus team of Silicon Photonics experts?
And one interesting observation is that while exit feels like a bad thing, those 100-plus engineers, I imagine, have and can find places in other parts of the industry, of the marketplace, because the technology continues to expand in other areas. And so it's not a negative per se on the overall perspective. It's a business decision that was made to support the bottom line of a company. But when we think back to 2016, this is a schematic that was in the book that talked about what's needed for Silicon Photonics to reach its tipping point. And so we've seen things like, volumes of larger than 1 million per year. So we are well aware of Intel at very high run rates that supports that observation. Higher degrees of integration that's happening in many different instances. But the one that we wanted to point to, which had always been acknowledged as a challenge, is the packaging part, the laser part, and particularly the fiber attached part. And so this is one of today's problems that, while there are solutions, it will require a number of innovative steps over the years to come to really reach the scale that's needed to support the market for this to be a tipping point type technology. And
sorry.
No, go right ahead. Carry on.
So, why is this important? If you look at existing systems in the data center, there's typically a large, for example, switch chip in the middle of a motherboard, and there's pluggable optics on the front plate. So you have to get the signals out from the chip all the way across the printed circuit board to this front panel containing optical modules. There's a couple of steps that are likely to happen as a result of switch chips getting more powerful. And this is what's happening every 2 years. So the capacity of these switch chips is doubling. And that means that the input and output data to feed these chips has to double, which puts demand on how you design the printed circuit board because the signaling is moving faster. But also you've got to have either more modules or faster modules, which again is a challenge. So there's 2 approaches that can be taken, or 2 steps. The first one is very much associated with COBO, which is the idea of embedding modules or optics close on the motherboard, closer to the chip. And what does that lead to? That then allows you or simplifies moving the electrical signals from the chip to these onboard optics. And then on the other side of this onboard optics, it's just fiber all the way to the front panel. But you can go a step further, and this is where it gets interesting, where you can actually use what are referred to as optical engines or chiplets, and you embed those along with the switch chip in one big package. And this leads to 2 more benefits. So again, it simplifies the serial interfaces going from the chip to the optics, because the optics is right next to it. But there's also another subtle benefit, which is the whole I/O issue. The amount of pins, the amount of signals moving around, especially as you increase the capacity of the switch chip, you have much more scope in terms of I/O, in terms of how you can design within the module. It's all to do with interposer technology, the pitch of these connectors and so on. So what are we talking about here? We're talking about moving from a very successful existing model of pluggables in 1 or 2 steps to something called co-packaged optics. And what is significant about this year is that the companies we know have been developing this technology have finally demonstrated their technology, and they've even reported the benefits in terms of the power savings. And this is important in the data center. It comes back to the basic discussion we had at the beginning, where as performance of system goes up, there's still only finite power in the data center. So you've got to do more with the same power. That's one comment. A second comment is, okay, So when exactly does this technology come into play? So if you ask these companies when exactly this is going to happen, the consensus is that it is going to happen. And I think the industry agrees that it's going to happen simply because, as we'll show in a later slide, that this doubling of switch chip just continues and continues. And at some point, pluggables will become too taxing to do. However, pluggables, at least for the next 2 generations, can do the job. So this is a really important development. And again, just to mention the 4th column, it's not just switch chips. There's a huge market for switch chips in data centers. The biggest data centers can have as many as 50,000 switches. But this is appropriate to different technologies. And in this case, Intel and Ayar Labs collaborated on a design for an advanced radar system, which used one of its advanced FPGAs in these optical engines. And it goes back to the comment we made about Intel with its sort of huge portfolio of chips. This is a technology that's applicable in more than one area, but the immediate issue is switch chips. And so this has been a significant year in terms of co-packaged optics. And the next slide will show why this is far from trivial.
And so we tend to focus on the performance that's needed from the switch chip and perhaps specifically from the chiplets to provide the bandwidth for the system to perform. But the real world necessitates scientists and engineers to roll up their sleeves and to solve some real hard problems that are not just technology-based, but that are also people-based. And so in this scenario, in the middle, we have an ASICs. So that is coming from a CMOS fab somewhere. In the yellow, we have some chiplets, and that is coming from some optical engineers or some firm that's associated with the design and development of that. And then further out in the gray, we have some fiber, and all of these things have to work together and connect together. And while fiber, for example, have been developed for transmission over long distances, the temperature and the environment that it now finds itself for these applications is not the same as what's been used in telecommunication. The temperature is quite a bit higher here. In addition, the numbers of fibers that's needed to support this very small cross-sectional area, the type of fiber, the alignment, using things like polarization maintaining fiber or even multi-core fiber or arrays. These are all challenging, and these are not problems that can be solved as individuals or as alone, but they need to be solved as systems. And so groups of companies or groups of individuals need to come together in order to bring these solutions to market. From a long-term temperature and thermal reflow perspective, it's not just the fiber, but things like adhesives, the coatings, ferrules, colors that goes into the coatings for identification purposes are issues that need to be solved. And then while these are solutions that are coming to market today and that where there are collaborations working on these things, on a long-term perspective, these feel more like stopgap measures. These are short-term solutions to aid. These are Band-Aids. They work now, that's fine. But as this really grows into, as Silicon Photonics grows into other market segments and explodes and becomes truly disruptive, we're talking about solutions that need to be much more integrated, needs to be much stabler. We're looking at things like optical circuit boards for connectivity. We need to improve things like insertion loss, propagation loss, for adjustments like polarization and aging. So it's a tremendous problem from a material science perspective, but it's also a problem that requires integration amongst groups of individuals who are in various organizations and various companies.
Okay, so this goes back again to what we were saying about switch chips doubling. And what we're showing here is a sort of inexorable trend to parallelism. And we'll explain that in a second. But parallelism is, again, what you would want because it drives integration and it plays into the hand or benefits Silicon Photonics. So at the bottom, we're basically showing where these Ethernet switch chips are up to. So we already have 25.6 terabits, and the next one will be coming in the next year and a half in terms of 51.2, and there's already been spoken of as 100 terabit chips. And this has an effect on the I/O, of course, of these chips. So it comes back to the whole discussion of why co-packaged optics is needed. We're talking about serial interfaces that can either be at 50 gig or 100 gig, and we're talking about hundreds of them coming off this chip. Takes a lot of power, takes a lot of real estate. And of course, if you double the chip, you have to double the capacity. So you either have to increase the speed, which in itself is challenging because we're talking about really high speed electrical signals and the whole issue of signal integrity. And you even have to increase the number of them. And again, there's at some point, there's limitations on this in terms of pitch and so on. But basically, people are talking out to 100 terabit. So if you ask people, when is co-packaged optics likely to appear? Well, what was sort of suggested before, that even at 25.6, it could appear. It would allow data center players to play with this. And even within a co-packaged chip, it could be operated in a hybrid form. So some of it will actually be fiber coming off of it, and some of it could drive existing pluggables. So on the front panel, you would have both. But what are we also showing here? So first observation is that the pins and the speeds of these pins is going up. So that is a form of, if you like, of parallelism. But there's other things going on here. So what can help? Well, if you go from 100 gig signaling to 200 gig signaling, and this is something that the OIF has started, but there's no reason to believe that going from 100 to 200 gig speeds will be any easier than how long it's taken to get to 100 gig, and that's work that's still being finished. So we're probably talking about 5 years of effort. So only in 2025, when perhaps the chips have achieved 100 terabits, could this technology start to be seen. And then there's another issue going on here, which again affects pluggable modules and affects the whole industry. It's Ethernet. So in 2017, 400 gigabit Ethernet was finally defined by the IEEE, but it's only now that that technology is starting to appear in volume. But the point being that the work hasn't started for the next rate, or it's on the verge of starting. And it's not even known at this stage what the next rate will be. So will it be 800 gigabits or will it be 1.6 terabits? But again, we're talking about 4.5 years effort. If 800 gigabit is produced, will that be sufficient bandwidth by 2025? And if they decide to do 1.6 terabits, is that too big a jump? And just one last observation. So if you look at pluggables, what the industry favors, and not unreasonably, is 4 channels. 4 channels of electrical signals going in, so in the case of 400 gigs or 100 gig channels going in, and also 4 channels coming out. This could be 4 wavelengths on a fiber, or it could be 4 individual fibers carrying a 100 gig signal. But if you assume 800 gigabit, that could be 8 channels, or if the technology for 200 gig electrical is available, it could be 4 channels. But if they go to 1.6 terabit, by definition, it's going to be 8 channels. So there you've already got a doubling of channels. So why is all this important? Because there's an underlying assumption here, or there's an underlying trend. It's going to take time to improve electrical signaling, and it's going to be a huge effort just to get to 224. So this means more lanes. More lanes plays into the hands of integrated design versus, say, doing it discreetly, and especially at 8. And so this is the trend. And just one other comment, not that long ago, the CW WDM MSA was formed, and they're already working on a wavelength plan for what will be required for multiple channels. So where will this exactly play out? Well, co-packaged optics is one place, but not just that. But what it points to is that the industry is already thinking about multiple wavelengths, so 8, 16, and 32, and 2 different grid spacings. So they're preparing the ground that people will know what to be able to use when wavelength counts or channel counts do get to 8 and above. And of course, there'll be compliance so that a design that's produced by one company will still work with a design from another. So inherently, there's a parallelism trend going on, and this benefits silicon photonics.
Yeah, so
Hey,
more.
Roy and Daryl, just a friendly reminder, we're about 40 minutes in, and we're starting to get some good questions coming in.
Okay, we're gonna skip really fast in a second here. So parallelism, very important for higher bandwidth to support the evolution of the marketplace. Silicon photonics is a big driver. The supply chain is being impacted by silicon photonics. And so we showed two pictures, the existing ecosystem as was defined in 2016 in our book, and then the new order enabled by silicon photonics is shown on the right. The existing ecosystem is already being impacted, well aware of discrete components, things like modulators, lithium niobate, for example, being replaced in a number of instances by silicon photonics-based circuitry. So we're not quite yet to the one on the right where there's a new order that's driven by the foundry and that's driven by the IC vendors. But we're making significant progress, and we're definitely going in that direction. In the interest of time, I'm just going to rattle through. Roy, you want to comment on this?
Okay, so this is a second market research firm, Yole, that allowed us to use their slide. And basically what they're talking about here and what's important, this comes back to that very first quote by Professor Batts that we mentioned, that silicon photonics is starting to be used for the other markets besides telecom and datacom. And they actually call out, or they forecast the size of these. So if you look at the total market in 2025, it's still only a fraction of a few percent of the total market. But these markets are starting. And if we could just go to the next slide, Daryl. So there's three markets in particular that Yole calls out and forecasts, which is fiber optics, biosensors, and LiDAR. But again, in a recent talk given by Professor Batts, this is a subject which he researches and obviously it's work that's done by the likes of IMEC, it's all the other applications. But this is a more comprehensive list of what silicon photonics is and could start to be used for. And just one observation and then I'll move on. There's mention here of computing and sort of more exotic styles of computing, but this is just exactly the sort of technology that's being referred to as beyond Moore's law. Other types of ways of doing things could be more efficient than the existing silicon, which is slowing down. So here's an example of silicon photonics being suitable for beyond Moore's law, but silicon photonics actually being used for some of the other elements of beyond Moore's law. Okay, Daryl.
Yeah, so what we said in 2016 was that, hey, datacom and telecom were the big market opportunity through 2026. Yes, sensors to come in 2021 and 2026, we're seeing that. No killer app yet to emerge. Agreed, that's correct. That's where we are today. We also said that there would be sliceable transceivers that would emerge. We're not seeing that, and so that's one I would say we stepped out, and that's not happening. And then we mentioned a number of areas where there will be evidence of it being a disruptive technology. The chip industry will ultimately drive the optics. And that the interesting one is that people will be the biggest problem, i.e. the chip versus the photonics community. And that is, in fact, recently Professor Batts pointed to made the same observation that we heard from Professor Kimberling back in the 2015, 2016 type timeframe. And so this is, it's not just a technology, but it's a marketplace where we're bringing together two very different groups to make something happen. So with that, we wanted to give kind of a final 2020 takeaways where we are in terms of market growth, $1 billion in 2018, 2019. That's very good. Positive outlook for growth, great. However, there are two dominant players really, Cisco and Intel, and so that $1 billion is shared. Most of that is shared by a small group, and so interesting observation. We have to continue to grow the market to keep the number of suppliers financially viable. Roy, the landscape?
Yes, this comes back to there's probably 10 to 15 foundries. So there's been real progress in the foundries, and this is what you want. If you're a company that has silicon photonics expertise, or you use a design house to make your chip, you want to be able to make this. And this is something that's maturing through a lot of hard work. Again, we pointed to this issue of acquisitions and strategic collaboration. So again, a sign that the technology is maturing and how companies are working together or being acquired is showing a growing maturity and recognition of the importance of the technology.
And we described the co-packaging emergence, only demos to date, but quite important. However, we also pointed out that pluggables are still available for the targeted applications that were demonstrated. Another interesting or very important observation by the suppliers of the co-packaging solution is that the improvement in both power consumption and cost when compared to pluggables.
And again, parallelism, it's an underlying trend. This is good news for silicon photonics, or for integrated optics, but in particular for silicon photonics.
And then with respect to the supply chain, the foundry involvement, critically important. But today it's still the optics, not the chips players that's driving silicon photonics. And the chip designs and photonics remain separate worlds. We anticipate this will change, but this is where we are in 2020.
Okay, and then the second wave, this is perhaps, again, it's not necessarily visible, but this is where silicon photonics starts to be used for different marketplace. So it implies new players, new markets, new requirements. And of course, it will drive volume. Some of these applications will be very high volume. And it will also lead to driving platforms, especially as it goes into manufacturing. The underlying silicon photonic platforms will be different wavelengths. These are different applications of silicon photonics than what we've seen to date for telecom and datacom. And this is what, if you're talking about a technology that starts to be ubiquitous, again, this is a development that you want to see, and it's starting.
And finally, with respect to silicon photonics, since 2016, definitely it has become an established technology, but we also point out it's not yet disruptive. The tentacles are there, the pieces are there, the growth is happening. That's going to take time, but it appears to be well on its way. And with that, we thank you for your time and for your kind attention.
Yes, thank you.
Excellent. Excellent, good stuff. We have a couple of questions that have come in. I'd actually want to jump in with my own first, and that's to ask you whether this has become a fertile field for startups. You see a lot of startup activity going on in silicon photonics, and what kind of companies are getting funded?
Oh, Roy, you want to take that one, or?
Let's just say this, Jim. If you look at first of all, there are silicon photonics startups in this marketplace. In other words, for telecoms and datacom, not many. But if you look at some of these other applications that we're talking about, this second wave, you actually look at some of the names. So there's probably about 20 or 30 or even as many as 40 in total that are busy in different areas of silicon photonics, some of them quite distant from what we're talking about here in terms of telecom and datacom. But there's definitely startups also. So I wouldn't say it's huge, but it's healthy.
So given that there have been all of those acquisitions that you were mentioning, that would suggest that there's a good pathway for startups in the space.
Yes, and but these companies work really hard for quite a while. In other words, they were bought when they were pretty much established companies. But yes, you could, if you look back in the history from now and looking back for the last close to a decade now, you could say that almost all the significant startups have been acquired, which is quite remarkable.
So let's jump in on some of the questions that have come in. So one of them, the first one. Could you talk about any other technologies? I guess this would be alternatives to either the status quo or silicon photonics in general.
Well, I think one of the important things that we're careful about is to say, use the term integrated photonics and not always say that it's silicon photonics per se. So silicon photonics plays an important role, but of course there are different material systems that can provide solutions to some of these problems. The silicon is unique in that, given the chip industry, it's unique, but we're also careful that there are other paths to this.
Okay. So with the worldwide pandemic, have you seen any noticeable impact on R&D or other investments in this area, either short-term or long-term?
Okay, so the answer is no, not yet. In the great scheme of things, you could argue that telecom and certainly the data centers in terms of their results have shown no sign of it. So I don't see any impact on the data center players. Telecom is a little bit different, and in a way it's still too early to play out. So you could say that the whole issue of people working from home, or the importance of broadband or networking in terms of doing stuff in its current environment, it's perhaps strengthened the proposition or highlighted to people even outside the industry just how important and strategically important it is. But I would also argue it's a little bit early. So things have changed. How do you develop standards if you're not meeting people? Or there's only so much you can do online, and people probably do a really good job. So it's a complex question, but the answer is I would say it's just a little bit too early, except this has to be an industry that's in a better position than most because of the strategic importance of what telecom and datacom players are allowing you to do as you're in lockdown.
But at the same time, the impact is associated with the everyday versus the future. And so what I must do now, I must do it now, and I'll work hard to get it done if it means driving revenue and things like that, given the challenges of the pandemic. But if it's a future thing, it's much more difficult to get done. And so I can only imagine the collaborations, the research and development to some level will be slowed down. But we've yet to see that will come. So while we will see that in the future is what I believe.
Yeah, I think the question may also have been going towards the supply chain disruptions that we were seeing in optics earlier this year, and whether there is a movement to brace against that in the future.
Sorry.
No, go ahead.
Yeah.
Oh, I would say just following the market research companies, they've not called this out yet, and they do see quarterly figures. So I would argue the evidence is not there yet. Okay. So it's positive. It's a positive answer. It's not been affected.
So I really like this next question, which is, since you published the book, has anything happened in the world of silicon photonics that has really surprised you, or is everything still playing out pretty much as you predicted and expected?
Okay, so we'd like to claim that we were all knowing, and we're not. But to answer the question properly, it's only 4 years since we published the book, and despite all this change that we talk about, it takes time in photonics for things to change. But let me just highlight two things. One we already talked about, which is co-package optics is a big deal, and companies have demonstrated the working of that. And that is a significant development. And another thing to say, which perhaps isn't always acknowledged, is if you look at coherence. So when Silicon Photonics first started out, and we're talking about in terms of products only perhaps even a decade ago or 8 years ago, people were seeing it as a datacom technology, and perhaps to a degree a little bit of networking. But if you look at how quickly Silicon Photonics has advanced as a coherent technology, in terms of it now offers speeds which are very close to the highest end indium phosphide, and distances that includes subsea links, so not ultra long haul, but subsea links. In a way, this is remarkable how sort of silicon photonic modulated technology has advanced. So these are two things worthy of comment in what is, relatively speaking, a very short time span. I don't know if you've got anything to add, Daryl.
No, well, I guess a little, the continuing appetite for the equipment vendors to acquire the Silicon Photonic companies. I'm not sure that I would have said that or predicted that 4 years ago. And that I would think, I said, kind of surprised me.
So you were surprised by Cisco and acquiring Acacia?
Yeah.
Yeah.
Well, okay, perhaps I'm benefiting from hindsight. I certainly didn't see Cisco acquiring Acacia, or I wouldn't necessarily name, but let's just point something that we haven't really discussed, but very briefly. And that is the importance of pluggable, coherent optics. And this also explains why Nokia acquired Elenion. It's not just within the data center. And this is an important market in the evolving story of coherent or telecom transport. So Cisco acquiring Acacia, you can say kudos to Cisco. It perhaps could have been someone else, but this is one of the factors why people are acquiring Silicon Photonics. It's not the only reason, but in the case of Elenion and Cisco in particular, Acacia and Elenion, this is part of the reasoning, an important part of the reasoning why they needed this. This is important for all the system vendors to equip their own equipment and across divisions within big system houses.
Okay, only a couple more minutes here, so let's see if we can get to a few more. Can you speak to multi-mode versus single mode solutions and the need for co-packaged optics?
Yeah, I would say that this is another surprise to me. There's almost no discussion of multimode as a viable path. Almost everything is a single mode focused solution. I mean, multimode offers a lot of advantages, a lot of positives, and so I'm not sure why this is the case. But from where I sit and my interactions, I'm not seeing a lot of effort or discussions or development on the multimode side. And
sorry about that. I went on mute there. What is a reasonable timeline to see co-packaged being adopted by bigger players like Facebook and Google?
Okay. In a way, I would like to know. So let me just say one thing. Facebook and Microsoft came out with a sort of specification to help guide the industry in terms of co-packaged optics. So obviously Facebook is one of the players that is interested in this technology. They all are, but I'm just pointing out that Facebook and Microsoft are pushing the industry a little bit on this to help shape what was happening. But it comes back to that question versus you can trial the technology, you can give it a go, you can start to get experience in terms of operations. But when do you actually need it? So I can't give you a proper answer on this. It's quite possible that they will adopt it early, but in certain volumes, just to see how it works and gain confidence in it. But when is it actually needed? That's a question. It could be at 100 terabits. It may even be what comes beyond that. But it's that sort of timeline. So we're talking about 5, 6, 7 years. Towards the end of this decade, I imagine you will see co-packaged optics being used to different degrees by all the large web scale players.
Okay, we're really right about at the end of our time. So let's take one more question here. Going through, I would say, how about this one? What would really be the tipping point between COBO, onboard optics, and co-packaged optics, CPO? Will the market skip COBO and jump directly to CPO? Will this be driven by bandwidth or integration challenges?
Okay.
Sorry about that.
Yeah. So the evidence so far is Microsoft is obviously a proponent of COBO, but how far widely will COBO be adopted by other players? In fairness, I don't know. This is perhaps a question more suited for market research companies, but I would say that it's an intermediate solution, and there's been a lot of discussion about this as to whether you need to go in steps or make the bigger jump. I would make the observation that if you're already seeing demonstrations of working co-package optics, and COBO itself is looking at co-package optics, you will see some deployment of COBO. But I think perhaps another aspect of that importance of 2020 demos that happened earlier this year is that there's an element of pushing this technology on. So there's still challenges, but it's almost appearing sort of relatively early in terms of its potential. Doesn't mean it will be deployed. So I would argue that COBO is an intermediate state that perhaps will be adopted widely by a particular web scale player, but will it be widely adopted by many players, or will they jump to co-package optics? I would argue it's the latter.
Yeah, and I would agree with Roy.
Right, excellent. Well, we've come to the end of our hour here. We still have a number of unanswered questions that unfortunately we couldn't get to, but I think we will get to them and answer them offline. This webcast will also be available as a recording for people who want to look at it. I'd also like to encourage both of you, Daryl and Roy, on your next updated version of this book. I hope you're getting started on it already.
Thank you.
Thank you.
Okay, and with that, I think it's time for all of us to sign off. So thank you, Roy. Thank you, Daryl. Thanks
Thank
to
you
Cobo
all.
and to DuPont.
And
Thank you everyone
Thank
for
you all.
attending. And thanks, Jim.
Yeah.
Thank you, Jim.